Okay. We've had an adventure, Zoom just left us. And updated what I wanted to do or not. So, got a couple of problems here. I'm gonna do this when we got two functions, f of x and g of x. I want to show whether f circle g of x is equal to x, g circle f of x is equal to x. Y'all have heard this twice already. I apologize, but we do want to get it so that you have access to it if you need it. So f of g of x, we're placing x by g of x in the f function. We're going to get 2 g of x minus 3. G of x is x plus 3 over 2, so this becomes this. And now we want to know how to simplify this. And people had some trouble with this. Some didn't, some did. Okay. Open math is going to tell you cancel the dang 2's. People don't know the rules for cancellation. So, yeah. When you get to a point like this, you see what you want to do. Okay. You want to make sure that you really can do it. To make sure you can really just get rid of those 2's so that you do get just plain old x plus 3 down here minus 3. You have to understand the rules for fractions. So you can write this thing here of this expression as 2 over 1 times x plus 3 over 2. Okay, 2 over 1 times x plus 3 over 2 is identical to this. We just replace the 2 by 2 over 1. Then we can, since we multiply numerators and multiply denominators, the result doesn't matter if the 2 is here or here. It's going to come out the same. We're going to be multiplying 2 times 1, whether we do it this way or this way. So this is clearly okay. But then, of course, 2 over 2 is 1, and 1 is still 1. And 1 times, well, x plus 3 over 1 is just x plus 3. And 1 times the quantity x plus 3 is just x plus 3. That's why we could cancel those 2's. Okay. And I guarantee you, I have to talk about this because people don't know the rules for canceling when they come out of the prerequisite courses. Never. You know some rules, but then they'll try to subtract this 3 from this 3. Sometimes even worse. Okay. Why can't you do that? Cross out the 2's. Why can't I cross out a 3 and a negative 3? Well, because the rules of mathematics do not permit it. Okay. So they do permit crossing out those 2. Okay, so we have that expert, but if you're going to cross 2 things out, think this through. Can you do this? Okay. Doesn't work otherwise. And the rule is you can only cancel factors, but nobody knows how to factor. Well, many of you do know how to factor, but a lot of people don't. Even though they've had the courses where that was taught. Okay, x plus 3 minus 3. That can re-root as x plus 3 minus 3, and that's equal to x. Okay, and g of f of x, well, that's very straightforward. When you do the substitution, you end up with 2x minus 3 plus 3 over 2, and everybody did the substitution right. You can then do the minus 3 plus 3 is 0, giving you 2x over 2. 2 divides into 2. You might be tempted to cancel, but here are the steps, very similar to the steps we had over here. Okay, so you want to think these steps. Make sure that it's a valid cancellation, because you're going to be tempted to cancel things that don't. And if you're not clear on what you're doing, it's not going to work. You're going to be in trouble. Okay. Anyhow, there it is. Now, for the okay, okay. So we have these 2 functions. We want to form the composites f circle g and g circle f, as it says over here. So here they are, f of g of x. We plugged in g of x for x. And here we have it, and g of x is 1 over x squared. We get this. the algebra of simplifying this. And for purposes today, it was fine just to leave it like this. I just want to see, how to do compost, but you are going to have to do algebra. You're going to have subtract fractional expressions, so you might as well see what you do with these expressions. So we have, first of all, 3 times 1 over x squared. Well, you could write 3 over 1 times 1 over x squared, multiply the numerators, multiply the denominators. You're going to end up with 3 over x squared. The 7, well, we got a fraction here and we've got a number here. We're going to want to add these. We're going to want to have a single expression, a single numerator and denominator under the square root sign. To get that, we multiply the 7 by x squared over x squared. Same as multiplying by 1, since x squared over x squared is just 1. And we write it as 7 over 1 times x squared over x squared, just to be sure that we're following the rules for multiplying fractions, which, as I keep saying, get more and more confusing as we go further into the course. In a month, you'll be glad you got it straightened out. Okay, so that comes out 7x squared over x squared. I think everybody's okay with that. And then we can just combine the numerators, 3 minus 7x squared over x squared. Okay, now, where we were when Zoom so rudely interrupted us, I made a couple of mistakes too, so maybe Zoom was just trying to be merciful on me. What's the domain of this expression? Well, people have told me that x can't be 0. Okay, and they said this thing under the square root has to be greater than or equal to 0. Okay, well, here's what we do. And I'm probably not going to ask you to do anything this complicated until we get studied inequalities in a few weeks. But that's something you should know. So hopefully it's familiar. And we want to see why we need to do this thing. So we've got 3 minus 7x squared over 2 greater than or equal to 0. So use this as a little refresher on inequalities. How do we solve this for x? Well, first thing we do is we multiply both sides by 2. Well, 2 times 0 is still 0. But 2 times this just gives us 3 minus 7x squared. So that's a pretty straightforward rearrangement. Now, again, you want to think, well, can I do that with the 2's? Maybe you didn't just do that with the 2's in the previous problem. But that's the way it works. Well, we did it on a previous problem, so I put a 2 here instead of an x. Please feel free to look at me like I'm crazy when I do stuff like this, okay? X squared, not 2. Okay, so now we're going to multiply both sides by x squared. Okay. When we do this, we don't know what x is. And there's one number that x can't be. There's one number that we can't multiply by both sides of an equation or an inequality. So let me just ask you if you know what that does. I'm turning this off. Okay, people told me pretty well that we can't multiply both sides by 0 because 0 is the one number that wipes out all our information. And we end up with 0 equals 0, which tells us nothing about what x can be or can't be. So we've lost all our information. And problems. Okay. So here we have it. Okay, so can't multiply plus 0. So we've all of a sudden taken care of the possibility that x might be 0, right? Okay. So now we get this. You write out x can't be 0. Okay. Then we have add -3 to both sides. That's straightforward. You should write out the step, but gravity, I think everybody understands that. Now what I have to do is I divide both sides by -7, right? And this is wrong. What's wrong with this? Anybody see anything wrong? If so. Well, I'm not going to explain why, but yeah, okay, we got an answer here, maybe. Okay, very good. Somebody told me when you multiply or divide both sides by a negative, the inequality has to reverse. Okay. But what's wrong is this should now be less than or equal. Now, when we talk about inequalities in more detail, we'll see why that is. Okay. But now we get x squared less than or equal to 3/7. Okay. But what this says is then that, and I'm going to skip to the answer here, and I'm not going to explain this because we'll get to it when we do inequalities in a little while. Hopefully you remember, but this is one of those things that people don't remember well. Okay. You take a square root of both sides. Of course, if you have an equality, then x would be, because x squared equal 3/7, x would equal either plus or minus the square root of 3/7. And we'll be solving those types of equations soon to refresh you, but that's something you should remember from before. That should be familiar. So we get the brain working with that idea a little bit before we really start using it. And then we get this, which is a little harder to understand. Something's wrong with this because it doesn't make a lot of sense. That can be big. Oh, no, never mind. Nothing. I'm looking up at this. Okay. So x can't be too big because there's a -7x squared here, right? Okay. That confines x to this small interval. So there's our domain. Now, x is not equal to 0 because it's in the denominator here. But we got that out of here because when we multiplied by x squared, we got the x not equal to 0 for similar reason. We have to understand that detail. So domain is -square root of 370 union zero square root of 3/7. How to write a square root of this one on the board. Wrote that a little bit early. And close the bracket here. 3/7 is fine. That would make the numerator 0. That's fine if the numerator is 0. because numerator 0 doesn't occur when x is 0. If the numerator is 3 when x is equal to 0. Okay, so there's our domain. Our range. X can be as close to 0 as you like. Okay. Your numerator is going to be a number between 0 and 3. Okay. If you divide a number between 0 and 3 by a really small number, you get a really big result. You'll be counting to 0, or you'll be counting to 3 by zeros, okay? Then if x is a really big number, well, it can't be all that big. Biggest it can be is square root of 3 sevenths, negative square root of 3 sevenths. So the numerator, again, is going to be limited. But then you're dividing the numbers that are as close to 0 as you like. If you get any positive one you like. So the range would be all numbers greater than 0 or equal to 0. The numerator can be 0. The denominator can be as close to 0 as you like. And that gives you the range. So I'm not going to go into all that detail to do that symbolically at this point, but that's the kind of things you need to think about. If we do the G circle F, it's a little easier. Yeah, I guess. Okay, let me just check something before I go on. Okay, I'm not going to have time to do the G circle F for these functions, but everybody wrote it down right. The domain and range are actually a bit simpler. Your denominator is a square root, so it can't be 0. That means it can't be negative. So you're always going to get a positive result. So your range is going to turn out to be positive numbers. We need to move on and talk about transformations. And as I said, I think you're well prepared for this. To make this plausible again, we're going to talk about horizontal shifts because vertical shifts and vertical stretches are easier to understand. Just to convince you once more, I think we've done this already, convincing you that if you subtract 5 from x, it's going to shift your graph to the right, not to the left. Think subtracting moves things to the left? Well, yeah, it does if you're just doing the numbers. If you're doing a function, it shifts to the right. Note that f of x equals 0 when x equals 0. What value of x makes this 0? Show me with your fingers. Yeah, if x is 5, you're going to get 0, right? Well, that means the point where the function is 0 moves from x equals 0 over to x equals 5, right? Okay. So what happens here when x equals 0 happens here when x equals 5. Okay. What happens here when x equals 1 happens here when x equals 6. So the graph is shifted. So the rule is graph of x minus 8 is shifted. I better make that a now. Oh, okay. Is shifted. Eight units in the x direction. Not negative 8 units. And of course, within the graph of f of x plus 5, well, then to get 0, x would have to be negative 5. That's just a graph 5 units to the left. That shows you why, at least that point shifts 5 units to the left. And of course, x plus 5 would be x minus h for what value of h? What would h have to be to make x minus h into x plus 5? It'd have to be minus 5. H is minus 5, then minus h is plus 5. So open math is going to reinforce that idea. So, if you have a plus here, then it's just a graph to the left. But here's the rule, and the rule accommodates both cases where we shift right or shift left. Okay. Now, you know how to shift points. That's what you just did for the assignment. You just handed in, right? And we did that a week ago because I wanted to be sure that you knew how points shift. Okay, so when you ask the graph, when I ask you to take that graph and shift it whatever number of units to the right, you were doing f of x minus whatever that number of units are, whatever the equation of that function was, and you don't have an equation for it because it's one you just drew from more or less random points. Okay. But if that function is f of x, then the function you drew when you shifted it right was f of x minus whatever number of units you shifted it. Okay. Then when you shifted it up or down, usually use k for the number of units. There's a k units in the vertical direction. Shouldn't really say shifted by k units. I should have just shifted k unit, but and it have f of x next to k and it looked like multiplication. So I threw that by in there, just kind of separate. Okay. Now you did that. Okay. What was your value of k? Show me with your fingers. When you did the graph, how far did you shift it in the vertical direction? Remember? Well, okay, maybe you don't remember. Okay, you look back at your work and see that it shifted some. Okay, maybe -8 units, -7 units, whatever. That kind of depends, I think, on your letters. So it shifted down, so you'd say maybe -4 or whatever. Okay. And of course, you probably don't have enough fingers to do the negative. Because your number is bigger than that. Yeah, okay, that's all right. Negative. Okay. That works. Okay. And then f of cx. What's that do? it moves everything c times as far from the x-axis. So that points close to the x-axis don't go as far as points further from the x-axis. If you do this, every point goes the same distance vertically, okay? If you do this, points that are further from the x-axis travel further in the vertical direction because you're multiplying a bigger number by c. And you did that. Okay, and most of the graphs I saw look just fine. And the ones you actually did a week ago pretty much look good. So I'm pretty well pleased with those aspects, okay? Y'all are ahead of most classes for doing this. You're also getting it done. And that's kind of the sheet. You got to stay on it. People have a terrible tendency to get behind. It's much worse last year, worst I've ever seen, but that's, you know, people coming out of lockdowns and stuff like that. There were reasons for it. Okay, so f of cx moves every point every point c times further from the x-axis. Now, if c happens to be 1/2, then c times further is really twice as close, isn't it? Does that make sense? If I move things 1/2 times the distance from the x-axis. Okay, so I'm going to replace the word further. I'm going to say c times the distance. So I can accommodate things that go further and things that go close. If you use the word further, you're thinking further. Okay. And I think maybe I had one where you go twice as close, 3 times as close. That would be like c equals 1/2. And if c is less than 0, moves to the other side of the x-axis. And I don't know what's going on. But that's what I'm talking about is a times f of x. You're multiplying the y value by a. You're not multiplying x by a. Multiply x by c. I'm sorry about confusion. Got it. And what I'm talking about is what happens to y. So forget what I said about cx. This is a times f of x. Now everything I said corresponds to moving things further and closer to the x-axis. But that's what you get when you multiply the value of the function, the y coordinate, by a. Because y equals f of x. So now if y now equals a f of x, then the y coordinate is always a times as great as it was. Okay, so you move it a times the distance from the x-axis. If a is less than 0, the other side of the axis. The thing about f of cx is that moves things closer or further from the y-axis, and you can read about that. We don't use that transformation a whole lot until we get to exponential functions. So we'll talk more in detail about that. It can be a little confusing. Okay. What happens if you have an f of cx? I don't know why I wrote it down. I wrote it down, then I started talking. Okay, again, I think you've been well prepared to do this. I think you do okay on the assignment. These are your rules, they combine. And we've been talking about that for some time. Okay, so. If you have questions, but that'll be due.